Okay, welcome to part 4. So the first thing we are going to cover is CAD/CAM. So computer aided design or CAD. These are systems for creating, modifying and communicating ideas for a product. It includes the computer aided design of the pattern pieces and lay plan for a product as well. So a few examples of CAD programs here for you: Photoshop, TechSoft, 2D Design, Autodesk 3ds Max. These will then be sent over to most likely a CAM machine to manufacture. Just remember as well that you can use CAD programs for testing for non-destructive tests as well. So computer aided manufacture and computer aided design are very closely linked. So machines and processes that are controlled and programmed by computers to do a whole range of production processes. So for example, you can design something on Onshape, Autodesk, a 3D model on the computer, send it to a laser cutter or a 3D printer, and it will make it for you. So the CAD would be the program that you use on the computer. The CAM would be the 3D printer. So a few examples here for your laser cutter, which we have gone through already. We've got a 3D printer and also embroidery machines. Okay, just a little activity here for you to write down the advantages and disadvantages of CAD/CAM. If you'd like to pause the video and attempt this yourself, please do so. However, I've got a few here for you. So advantages of CAD and disadvantages of CAD first. So advantages of CAD can be more accurate than hand-drawn designs. It reduces human error. You can save and edit ideas, which makes it easier and cheaper to modify your design as you go along. You can modify existing ideas, which saves time. Disadvantages, however, the software itself can be expensive, so initial costs are high. There are free software packages, however. Staff need to be trained how to use the software, which also adds to costs, and it requires a PC or a laptop. Advantages of CAM. So in large-scale production, the results are consistent. They are always the same. Enables very high accuracy levels in large-scale production. Usually speeds up production for low-volume products as well. Disadvantages of CAM. The software itself is expensive, so initial costs are high. It can be slower than traditional methods for one-off or low-volume products, and staff need to be trained on how to use the software and machinery, which can be costly and can also take a bit of time as well. Okay, now we're looking at orthographic drawings or technical drawings. So these are drawings that is used to represent different views of a three-dimensional object. So you will see these in your Unit 1 and Unit 2 work. We have worked with them in the past. These are called technical drawings or orthographic drawings. Okay, so the first thing that we are going to be looking at is the first and third angle projection. So knowing the symbols that are on the orthographic drawing and understanding what they mean. So first angle projection is a method in engineering and technical drawing to represent a 3D object on a 2D surface by placing the object between the observer and the projection plane. Now, as you can see here with the first angle, look at the symbol there. You can see that it is back to front. So you'd have the front where it usually is. However, the bottom would be at the top would be at the bottom, right would be on left, and left would be on right. And it looks something like this as well. So if the symbol looks like you are looking away, so an angled away from it, that is a first angle projection symbol. Third angle, however, third angle projection is a method of orthographic drawing where the 3D object is represented by a series of 2D views, typically the front, top and right hand side. This makes a bit more sense where you've got the front of the front, top of the top, bottom of the bottom, left of the left and right at the right. If you look at the symbol, this portrays that for you. Now in WJEC engineering, this is the only one that we will use. This is the only one that you will see. So if you do see this symbol pop up in your mock exam, your GCSE exam, it is always going to be a third angle projection. If you do get a little bit confused of which one is which, and if you are a fan of The Incredibles, so Mr. Incredible's logo looks very, very similar to the third angle projection. So if you look at his super suit there and look at the projection logos, I have copied them down at the bottom for you. Okay, so on here we have got some drawing lines, hidden lines, center lines and center marks. We've got phantom lines, break lines, cutting, plane lines and dimension lines and leader lines there as well. All the information for these are available on the PowerPoint that I have sent you. Please don't go through them. They're also in your workbooks, which you have copied down. These are all the lines that you would find in a technical drawing. If you have a look at any technical drawing on Google or the technical drawing that we use in school, please make sure that you focus on these drawing lines, hidden lines, phantom lines, and so on. They are all there. Okay, moving back to electronics, something that we have touched upon in the past. I'm just going to go through all of these. So a cell and a battery. A cell is a single unit that converts chemical energy into electrical energy, while a battery is a group of cells that produce a steady supply of electricity. We've also got the voltmeter, ammeter. Please look at the symbols that we've got there. So a voltmeter measures the voltage, and the ammeter measures the electric current flowing through the circuit. Next here we've got the resistor and variable resistor. We have spoken about these in a previous video and in all previous lessons. So a resistor resists current, so controls the flow of current. If you have got a resistor, which is on the left hand side here, it is fixed. You cannot change it. It resists X amount, whatever the resistor does. A variable resistor, however, you can change, so you can make it the flow of current go through more or less. A lot of these are used on volume control. So if you've got a speaker with a volume control and you turn it up, that is a variable resistor. So the higher it goes, the more current that goes through, therefore the louder the music becomes. A switch is a control method of cutting power from the circuit. Please take note of the symbols as well. And a motor, a big M in the middle, a motor is used to power a product. Lamp and LED, or a light emitting diode. So look at the symbol for a lamp. You've got a big X there. A lamp is used to provide light on a circuit. These are usually halogen lamps. And LED, light emitting diode, are very rugged. They are tough and produce a brighter light than traditional lamps, whilst using less energy. Because they are using less energy, these are considered more environmentally friendly. Okay, coming to the final bit of this video. So now we are looking at machines, maintenance and health and safety. So engineering machine maintenance is important because it helps machines work safely, efficiently and for a longer time. Regular maintenance reduces the chances of breakdowns, improves performance and helps prevent accidents. It also saves money by avoiding costly repairs and keeping production running smoothly. So on here, I've got a few machines with their maintenance. A lot of them you can use for any machine, but there's a few extras that I put on there. So maintenance for scroll saw, fret saw, you check the blade for wear or damage and replace if necessary. Make sure the blade is correctly tensioned. Clean dust and debris from moving parts. Inspect the power cable and plug for damage. You can do that for every single machine. Maintenance for a bandsaw, check the blade for sharpness and cracks, ensure the blade is properly tensioned and tracking correctly, lubricate moving parts if required, and again, clean out dust from wheels and lower cabinet. Some extras from this is checking that the emergency stop button works, making sure that the cables are not broken, making sure that the extractor works. There's loads. Laser cutter, So laser cutters work with lenses and mirrors, so you need to make sure that they are clean to get a clear beam path. You need to check the water cooling system if you have a water cooling system in a laser cutter. We do not at school, but more industrial stuff, industrial laser cutters do. Inspect the exhaust system and filters for blockages and make sure the laser tube is functioning correctly and not near end of life. On here we've got the center lathe, so check tool post and cutting tools for wear, clean swarf, so that's the debris from metal, from bed and lead screw, lubricate all sliding surfaces and moving parts, inspect belts, gears and guards of wear and damage. CNC router, check tool bit is for wear and damage, inspect cables and connections for sign of wear, clean the working bed and remove any material buildup, and ensure software and firmware are up to date. If it's not up to date, the machine won't work. Maintenance for the milling machine is very similar to the CNC router. So inspect cutting tools for wear or damage, clean the table and remove swarf, again very similar to the center lathe there. So swarf is the debris and the waste from metal. Lubricate moving parts and slides, and check the spindle and feed mechanisms for smooth operation. Pillar drill, check that the drill bit is sharp and secure by tightening the chuck. Make sure that the chuck operates smoothly, lubricate moving parts such as the spindle and feed mechanism, and inspect the guard and emergency stop for correct operation. Now, if the machine has a guard, so stuff like the scroll saw or fret saw, band saw has a guard at the top, pillar drill has got a guard, every tool has got a guard really. So you need to make sure that the guard doesn't have cracks on them, that the emergency stop works for every single machine. Quick maintenance on there. Belt sander, disc sander, very similar. So check the sanding belt or disc for wears and tears. Ensure the belt is tracking properly or that the disc sander spins correctly. Clean dust, collection ports and internal areas, and inspect the motor and switches for signs of damage. Okay, on here we've got some exam style questions. So machinery can cause a health and safety risk if not maintained correctly. Maintenance of this or these machines should be carried out on a regular basis. State 2 maintenance checks that should be carried out on these machines to ensure that it remains in safe working condition. So if you'd like to do these questions and provide 2 maintenance checks for a bandsaw, scroll saw, pillar drill and the center lathe, please pause the video and answer the questions. Now with this, with health and safety, I have really diluted this and simmered this down to key things. So 2 things that we know at the Oldham Academy North is that we must wear safety goggles to protect our eyes whilst we're on the machine. That's number 1. So if you ever get a question about health and safety on the machine, that's number 1. Number 2, you must wear an apron to protect your clothes and to stop loose clothing from being caught in the machine. That's your number 2. Okay, please in the exam don't write down safety goggles, apron. You need to tell me why you're using safety goggles and apron. Some extra stuff here for you. Press emergency stop button if there's an issue. So anything that goes wrong with the machine, you press that emergency stop button. Visual checks before using the machine is a big one. And again, we've spoken about this earlier in the video. Guard placed to protect the user, cover moving parts. Make this relatable to the machine. So pillar drill, guard placed to protect the user from the drill bit. If you're doing the scroll saw, guard placed to protect the user from the saw blade. If you're using the bandsaw, saw blade again. So whatever the tool is, that's what the guard is protecting. Okay. Right, finally here, if you'd like to pause the video, and again, you've got an exam style question, list 3 sequential steps the machine operator would need to take to safely carry out a practical task on a scroll saw. You can repeat this question for a bandsaw, you can do it for a pillar drill, belt sander, disc sander, doesn't matter which machine it is, you just need to know 3 ways that you can be safe whilst using those machines.